Welcome back. Today we're going to talk about 3.4, the properties of logarithmic functions. We're going to start with three properties here. The first one is going to be the product rule. The product rule looks like this. When we're working with logarithms, we need to look at exactly what our base is and what's actually inside the function. So if I have a log of base b, and this includes e, so that would be a natural log, but that's just log of base e, of two things inside, and I'm going to write it like this, of r times s, and those are going to be either numbers or expressions. We can break it up to make it look like this: log base b of r plus log base b of s. So if we've got a multiplication problem inside the log, we can split it into an addition problem. Second rule, quotient rule. With the quotient rule, we're dealing with something that's taking the log of base b of a quotient, so r over s. Now when we do this, it's important to remember that could also be natural log because the base could be e. And what I can do is I can split this into a log of base b of r minus the log of base b of s. Third one, power rule. For the power rule, I'm going to be dealing with a logarithm, log base b, again could be e, of something, so an expression to a power or a number to a power, and actually this is going to be, I said 3, but I was thinking 3, but it could be any number c, so it could be anything, it doesn't just have to be a 3. And what we can do is we can bring this out to the front, and we can say it would be c times log base b of r, so that exponent can come out front. What are we going to do with this? Well, they're going to give us a bunch of stuff, a bunch of expressions that they're going to either ask us to expand or condense, or to write as a sum of logarithms, or write as one single logarithm, something like that. So what I've got here is log base 10 of a multiplication problem, so 8 times x times y to the fourth. Well, really this is going to break into three things because I have two products, so I'm going to do log of 8 plus log of x plus log of y to the fourth. Well, what I can do is, because this y to the fourth is now looks like the power rule, I can actually make it even simpler. So I can say log of 8 plus log of x plus 4 log y. Well, actually I can simplify it even further, because this 8 right here, this can be written as 2 to the third power. So really I can say log of 2 to the third power plus log of x plus 4 log y, and I can do that one more time to make this 3 log 2 plus log x plus 4 log y. Okay, so that's completely written as a sum of or multiples of logarithms. That this would be a sum, obviously with three parts, and then I've got these multiples of logarithms here because of the exponents. Let's go to the next one. Now, again, if you'd like to try to split or try to do this one by pausing and coming back, you can do that, but I'm going to go ahead and roll straight through. I've got a quotient here, so I'm going to split it up. Log of the square root of x squared plus 5 minus log of x. And when I do this, I need to remember that this square root can be written as a 1/2 power. So this would be, I won't skip that step, log of x squared plus 5, and that would be to the 1/2 power, minus log x. And so I can bring my 1/2 out front and say 1/2 log of x squared plus 5 minus log x. Okay, so we're looking for things that can be written as exponents to use the power rule, or quotients that we can split them, or multiples that we can write as an addition problem. All right, I would encourage you to pause it here, but if you're not going to pause, or if you're pause and then back, we're going to go ahead and go straight through. What I can do is write as a single logarithm. So I see my minus, so I know I'm going to have a quotient here. So I'm going to say natural log. And what goes on bottom? Well, what goes on bottom is what is being subtracted. So I'm actually going to do a couple of things at once here. I know it's xy, but this has the 2 out front, which means it goes up here as an exponent. So this is going to be log, or natural log of xy, and then squared on the bottom. And on top is going to be this x to the 5th. But I can actually simplify this a little bit more because this is equal to the natural log of x to the 5th over x squared y squared. Well, now you can see that these squares cancel, this becomes a 3, and so I can say this is the natural log of x cubed over y squared. Okay, so there's a way that we could have a couple little elements going into, but in that case we were combining them instead of splitting them up. Go ahead and pause here if you need to. If not, we're just going to keep on rolling. So a single logarithm, got the plus here, so I know it's going to be multiplication. So I'm going to say natural log. And this 3 is going to be on this expression here. So x cubed y, and then cubed on the outside. And then multiplying that, and this 2 is going to go up here. So let's see, y z squared, and then that's going to be squared. I'm going to have some simplification to do here. When I distribute this in here, it's the same as saying x cubed 3 times. So that would be x to the 9th. Y cubed, and then y squared, z to the 4th. And so when I simplify this all the way, I've got natural log of x to the 9th, y to the 5th, z to the 4th. That's going to be my answer there. All right, so that's the basics of splitting and combining. Let's talk about change of base. What happens a lot of times is calculators will be able to evaluate a logarithm that doesn't have a base of either 10 or natural log. But if you've got a little bit older calculator, it's only got either log, which is base 10, or natural log, which is base e. And so what we need to do sometimes is to be able to use the different functionalities of calculators, or if we want to split logarithms into things that we can combine with others that already have a similar base, we can use the change of base. It looks like this. If I've got a log of base b of x, I can change it to a quotient and say log of a, which is base I choose, x, over log base a of b. Okay, so I am picking, so a could be any base. Okay, so convenient ones would be, like natural log or just log base 10, which is log. And then an important thing to remember is base goes on bottom. Okay, so the base goes on bottom. So whatever the base is, that's what's going to go down here at the bottom. So if we're using the change of base formula here, let's check out a couple of examples. I've got 3/16, so what I can do is the natural log of 16 over the natural log of 3, or I could do the log of 16 over the log of 3, and what I end up with is about 2.52 there. Okay, that just makes it easy, and then I can plug it into my calculator. Again, base 10, so I'm just going to go ahead and use natural log here. So 10 over the natural log of 6 is about equal to 1.29. Okay, let's do one more. If I've got a 1/2 on the bottom here, tricky but not undoable, we're going to do the natural log of 2 over the natural log of 1/2 here on the bottom, because the base goes on the bottom. And what I end up with is actually not approximately, it's actually equal to -1 there. And again, I could have done, log of 2 over log of 1/2. That would have worked. Same thing would have worked here. I could have used log in the middle there. Okay, but that's the basics of using the change of base formula.